All right, hello, thank you. We'll be switching gears just a little bit, but not too far. I am here today to talk about a project that is underway called the Great Lunar Expedition for Everyone, or GLEE for short. This project began really the year of the 50th anniversary of the moon landing. In Colorado, we were thinking about how can we utilize that moment in time to start galvanizing a new era of students to be excited about going to the moon. And I think what is very exciting is over the last 5 years or so, there's been a huge boom in excitement over doing this. So the mission overview of this particular project, GLEE, is that we have been developing a small chipsat-based technology to be distributed on the surface of the moon to do distributed network science, which I'll talk a little bit more about. But it's not just about developing technology. It's about developing something that we can then put in the hands of students to get them to learn about doing lunar science, be excited about it, and then engage them in the actual mission when it comes time to go to the moon. So a little bit more detailed ConOps here, detailed to the extent that we can have it. First, we have been developing these small Lunasats, and the idea is to have students participate in planning of the science that's going to be done on the moon. So these would be loaded into a deployer that would be able to be put on a lander or a rover, and then that deploys them out in onto the surface in a distributed network to collect data for up to 2 weeks. And then at the end, we would have a data set collected that we could then utilize and anyone could access to do their own science. So there's really 3 parts to the GLEE mission. And one of those parts is the STEM engagement part, which I'm going to talk about first. And then the second is, it is a technology demonstration. Can we utilize a small, inexpensive sensor package to gather meaningful data on the surface of the moon? And then if we can gather the data, what kind of lunar science can we attain? So first off, talking a little bit more about the STEM engagement, the global engagement part of this project. We kicked this off in 2021, inviting teams to the University of Colorado Boulder campus. And we had, at the time, we had 10 modules that we had developed that walked the student teams through learning about the Lunasat, learning how to use the Lunasat, test it, and then develop their own science cases. So we had 19 teams participate in that kickoff workshop. And the next phase of that, and as you can see, this was definitely still during the COVID times, but we persevered, moved on, and have developed a remote workshop. And this was the next step. We can't bring everybody to Colorado to do this, so we wanted to put it in a platform that was accessible by students around the world. And we have been very successful in engaging students. This workshop kicked off in 2022, and then we started shipping out kits to teams that applied to be part of GLEE. And for that year, we had live help. We had help desk hours. So we had students that were working actively on engaging with the student teams as they worked their way through the workshop modules. Now, the live help part is done, but all of the teams, and we have now 230 teams from over 30 countries right now, and that's about 2,000 students that we've reached so far with this project. And the exciting part about this is each of the teams have an advisor or mentor. And so what we are encouraging is as the students move on, that the mentor or advisor then recruits a new group of students to utilize the Lunasat kits and to access the workshops and go through those modules with new students. In addition to that, we've been adding new material to the online workshop for students to continue their learning. That was by great request of many of the students who have been involved in Glee. They send us messages all of the time. You know, when is the next module coming out? What do we get to do next? They're so excited about being part of this and being part of learning about going to the moon and what kind of science needs to be done. We have many of the Artemis Accords countries involved. We did another round of recruitment. As more countries join the Artemis Accords, we try to use that as an opportunity to reach students in those countries, to invite them to become a part of Glee and a part of the workshop. So we developed initially 10 modules. We now have 12 modules that are available for students, and we are in the process of working on some brand new ones. In addition to working through the modules about the Lunasat, where the students are really learning how do each of these sensors work? What do you use them for? What does the data look like? How can we use data? And what kind of sampling rates are important for various questions as you're learning how to use these sensors that are a part of the Lunasat package. So with the kits, we send them a complete kit so they have access to the Lunasats. We give them the materials they might need to do testing. Of course, many of our teams have gone way above and beyond and developed, new tests and new ways to use them. But that way, everything is self-contained and fairly easy to access. So it's not dependent on the students having access to, special equipment or special technology to be a part of it. We ship them the kit and they have everything they need to go through all of the workshop modules. So where we're headed now is we're very excited. We're going to be incorporating some of the Moon Trek work into a new module to help students really learn how to do mission planning. We're so excited about that. We have been reaching out to new teams, and it's a little bit funding dependent. We would love to do a whole new round of kits. We have continued to develop the Lunasat technology, and we've done a little bit of alteration of some of the sensors, chosen some better sensors, and we would love to do a new round of kits and send them out to teams as well. We are keeping the teams engaged through social media in many ways. Of course, we have the normal sort of social media channels of Instagram, LinkedIn. We send out newsletters to our teams and folks who are interested. And one of the latest developments is we now have a Glee Discord server. So the students can hop on there and chat and share ideas. And as well as we also have a Glee GitHub for code sharing. So lots of ways to connect teams, from very different parts of the world. One of the really exciting things that we've done this year is we have added some design challenges. So really these go out on social media to the teams and we say the latest one was a design challenge to design a deployer for the Lunasats. And then the teams actually submitted videos as well as a white paper on their design. And then the teams they win Glee t-shirts, which is it's a hot item to own. Not very many people have Glee t-shirts. But this really also helps, again, keep students engaged and gives the mentors and the advisors who are working with the students more things to encourage. And we found that some have even incorporated some of the things we've done into their curriculum. So like I said, we've have a total of 230 teams so far. This is just a list of the distribution of countries and how many teams we have had in the various countries. Like I said, we are hoping to be able to expand and do a second full round, inviting new teams and from new locations. So the future of Glee, some of this, of course, would depend on, we can't do science without data from the moon. So we need to get the Lunasats to the moon. So coming back to our ConOps here, you might be wondering, well, okay, how are the student teams connected to you going to the moon? And that has been something of much discussion. One of the very early ideas was, the students would build their own and that would go to the moon. But of course, there's a lot of control issues there with having people send you things and then you send them all to the moon. So we have sort of moved away from that idea to more of an idea that the student teams are helping to design some of the science cases for how that data is going to be collected, contributing to the code that runs the sensor network, and then, of course, having access to the data as it comes back from the moon. And that will be put into a data dashboard that can be accessed by anyone. And of course, they will be assigned their own Lunasat in a sense. So the teams that continue to work will have an identity with the Lunasat on the moon. The current version is version 7 of the Lunasat. This is a picture of the prototype because we are actually awaiting the Lunasat version 7 to come back from the PCB manufacturer, so it wasn't quite ready for a photo, but apparently my students have told me it will be there when I get back, which is very exciting. They're excited to do the latest round of testing. But it does have temperature sensor, accelerometer, magnetometer, a capacitive sensor, and then the way that these Lunasats will communicate is through RF transmission. So using a LoRaWAN network, they will be able to communicate back to the deployer, of course, to send the data back. And so something that is important to note is all of this work for the development of the Lunasats, the workshop, all pieces of this have been done by students, primarily undergraduate students. A few graduate students have participated in GLEE, but it is primarily an undergraduate student-led project. So as we are moving towards lunar deployment, we have been working on the prototype for the actual deployment of the Lunasats onto the moon and putting in a design that would be easily transferable from either a lander or a rover type deployment. And the way that this would work, one of the original ideas was to shoot it out of almost like a cannon spring type thing and fling them around, and all of us said, that does not sound like a good idea. Let's not do that. Let's think of something else. And so now the development and the testing is actually in the works for the current design of the deployment module. We're also doing a lot of testing of the Lunasats as a system this summer. Students are working on thermal survivability, doing more work with the RF communications protocols and how that works to move the data around, and working on power management systems. So in conclusion, we are very excited to keep GLEE going, get GLEE to the moon, and keep engaging students around the world. Again, this is an exciting time, and the more students we can get involved in thinking about doing lunar science, and so they don't have to become, just one type of engineer or one type of science. There's so many ways to access it, and in GLEE, the whole mode of GLEE is to get students engaged and understand that they have a place in doing lunar science. So that's it. Thank you.
Okay, we have room for one question.
Okay, thank you very much, Brian. When I got so excited at lunchtime because Brian actually told me about this project. So first of all, I want to congratulate you for actually taking this fantastic opportunity to, such a broad community beyond boundaries. So well done. I saw that there was one team in the United Kingdom, so I would be interested in knowing from you who they are and how we can expand those numbers, and perhaps at future ELSs, you could actually offer a workshop that you mentioned. So you would be welcome to do it. But closer to my own heart, we have a public engagement program called Living on the Moon, and I can't wait to see Living on the Moon with glee. So thank you.
That sounds wonderful. Yep, I look forward to it. Let's talk.